Welcome to this WiseOwl tutorial on advanced functions in Python. It's the second in a two-part tutorial on writing functions in this wonderful programming language. So here's what you'll learn in this second part of the series, in the mini-series. We'll learn how you can distinguish between keyword and positional arguments, and how you can force users of your function to use one or the other. We'll look at how you can specify arguments which are optional, that you don't have to pass in, but you can if you want. And then we'll go on to look at how you can pass an array of arguments to a function and how you can pass a dictionary of arguments, and I'll explain what these things mean. And finally, we'll look at Lambda functions, which have been promising for some time, which are another technique that you can use. At any time, you'll be able to click on the link at the top right of the screen if it's visible. Otherwise, you'll be able to use the link on the WiseOwl website or indeed on the YouTube site. And that will allow you to get at files to do with the tutorial or any exercises. But I think I'm about to disappear now, and as always, I'll let Sven carry on with the rest of this tutorial to guide you through the topics. So let's get started. So as an example of using named versus positional arguments, we're going to create a function called BMI, which will calculate anyone's body mass index, which is a measure of how overweight somebody is. It's not completely reliable, and I put a link to a BBC webpage proving this, but as an example of writing a function in Python, it's invaluable. So to create a function, you type def, and I'll call it BMI. Open brackets, and then I'll put my two arguments. The first one will be the height, which will be a float, because you don't have to be a whole number of meters. And the second argument will be the weight, which is also a float, because you don't have to be a whole number of kilos either. And your BMI itself doesn't have to be an integer, so this will return a float too. And that completes the definition of my function. So now I'm going to create a variable, which I will call body mass index, and I'll set it to be somebody's height divided by their weight squared. Sorry, their weight divided by the height squared, so I'll take the weight and divide it by the height raised to the power of 2. And then we can just return that. I didn't really need my variable at this stage, and that should give us somebody's BMI. What I can now do is test this out, and you're welcome to substitute your figures of your friend or relative if you like at this stage. So I'm going to create a variable which I will call my stats, and I'll set it equal to BMI, open brackets. So here's a terrible truth. I'm about 1.8 meters tall. I'm slightly overweight, 82 kilos. And so when I print this out, I think I'm going to see people recommend that your BMI should be less than 25. And mine isn't. It's 25.3, but it teeters on the edge, so that's probably okay. So that's a basic BMI function. Now, when I called this, I used positional arguments. I relied on the fact, as we have done throughout this tutorial series so far, that the first argument would correspond to the first argument specified in the brackets there, and the second one, 82, would map onto the second argument in the brackets. Now, you don't have to do that. What you can do instead is use named arguments. So I'm just going to rewrite this. And instead of using positional arguments, I'm going to actually name them. So I'm going to say where my height is 1.8 and where my weight is 82. And if I run that, I'll get exactly the same answer because it's doing the same thing. This has two benefits. One of the benefits is that it's much easier to read. You don't have to think, is that the height? Is that the weight? You can immediately see it. But the second benefit is I could, of course, put the arguments in any order I like. So I could put the weight first. So I'll set my weight to be 82 and my height second. It would still work. So it's undoubtedly true that named arguments are better to write. So why haven't I taught them yet? I guess the answer to that is even though they're better, very few people bother using them, and I must admit I don't usually. It's just so much quicker to miss out the names of the arguments and just put the values in instead. Now there's just one more thing to say about named arguments, which is that you can actually mix and match. So to prove this, let's create another variable. I think what we're going to do is show Winston Churchill's BMI. They're estimated figures. So Churchill BMI. And what we'll do to prove that I can mix and match, I'll start with a weight and set that to be, my notes say 95, which seems a bit much. And then the height is 1.68. Now, I don't think this is going to work. It's underlined it. And the reason is a positional argument can't appear after keyword arguments. So you can mix and match, but only if you do it in the right order. Now, if you think about it, this actually does make sense. Otherwise, having eliminated all the named arguments, how would it know what positions to put all the other arguments in? There'd be ambiguity. So yes, you can mix and match, but you have to do it in the right order. So let's try again. I'll start this time with a height, which in Churchill's case was 1.68. And now I've eliminated all the positional arguments. I can carry on and specify named arguments. So I'll put his weight with 95. I've only got 2 arguments there, but the principle works however many you've got. You can list out all the positional ones first, and then all the others can be named if you like. Check this works before I give my thoughts on that. I'll just run that. And you can see Churchill's BMI was a fairly overweight 33.65. So unless he was an elite athlete, I think it's possible he was overweight. Is this a good idea? I don't think so. I think it makes more sense to use either all named arguments or positional ones. I can't see the point in mixing and matching. Having said which, the next topic we're going to do will show how you can force people to specify some arguments as positional and others as named. When you're specifying arguments in a function, you can force your user to use them either positionally or by keyword. And here's how this works. If you specify a / as an argument, then any arguments specified before that in the list must be passed in positionally. And if you specify a star or an asterisk, then anything arguments after that must be passed in by keyword. So here's what this might look like for a complicated example, admittedly. So in this case, anything before the first /, so anything to the left of this, if you like, must be passed in positionally. So the first 2 arguments, you can't specify the argument name, you just have to put in the value. By contrast, the star means that anything following that in the argument list can only be passed in by keyword. Anything between those 2 can be passed in by position or keyword. So the syntax is reasonably clear. Whether you'd actually want to do this, I'm not so sure. Why not just give your user the freedom? But having said that, let's have a look at an example which actually uses these 2 symbols. So to illustrate this, I've created a new file called forcing-named or positional arguments.py. I've added in the comments from the slide we just saw, just as a little backup or a bit of information. And I've added in Stalin's BMI using estimates I got from Wikipedia, which don't seem entirely accurate. Now, the difference between the way I'm calling Churchill's BMI and Stalin's BMI is for Churchill's, I'm using keyword arguments or named arguments, as I was calling them earlier. And for Stalin, I've used positional arguments only. And all of this will work perfectly. So if I now try running that, and you can see Churchill was considerably more obese than Stalin, which is no great surprise. Although it did surprise me how short Stalin was. I never knew that. So now let's add in some twists. The first thing I'm going to do is type in a / comma. And what that will mean is any argument before that, which in this case is the height, has to be passed in positionally. So my prediction is this line of code, line 17, will crash because I'm not using a positional argument for that. Let's see if that's what happens. So if I run that, you can see it does indeed crash line 17, and the reason is it's got some positional only arguments passed as keyword arguments, the height. So what I would need to do is either remove the named argument, but I'm actually going to cheat. I'm going to comment that out. And then if I run this again, you should see that the second time it runs and gives Stalin's BMI, because for Stalin's I'm passing them both in positionally. So let's now reinstate that. So that's what forcing positional arguments does. Now let's twist it and force keyword arguments. So what this will do is say any argument after that, specifically the weight, has to be passed in as a keyword. So this time Churchill will work fine because I've done that, but it's Stalin will trip up over and line 21 will crash. So again, let's see if that's actually true. and it crashes on line 21. It's always nice to be proved right. It takes one positional argument, but I gave two. So to get this to work, what I would have to do is comment out Stalin's this time. And then if I run my code, you should see that I get Churchill's BMI. So that is how you can force a user to use keyword or use positional arguments. But I think, to be honest, one of the main benefits is understanding functions that other people have written for you to use. Just to take one example, supposing you have a list of 3 numbers. It's a list because it's got square brackets, and you want to sort it. You may have wondered why you always have to specify the reverse keyword, and the reason is this star there. By putting that in, the people who wrote this function ensured that any arguments you use have to be specified as keywords and not as positional, presumably to make it easier to understand what you're actually doing. So that's probably the main benefit of learning about keyword and positional arguments. In contrast to the previous section on forcing named and positional or keyword arguments, this is, I think, much more useful. I'm a big fan of optional arguments. I use them all the time. As an example, here's my BMI. I've copied in the function to a new file called optionalarguments.py and just added a line to print it out. And if I run that, you can see it says my BMI is what it was before. But is it? I'm not so sure. I guessed at my height in meters and I guessed at my weight in kilos, because to be honest, I still work in imperial units. Now, international viewers may be a bit baffled by these, but the UK still works to some extent in feet and inches and stones and pounds. So what I'd like to be able to do is to specify the same thing. So I'll just copy that line and repeat it. But this time, I would like to put my height in inches, which is 70-ish, and my weight in kilos, my weight in pounds, which is 178. And that will give me a more accurate view. But obviously, if I run that, it gives me my BMI of 0.04, and I feel it's more than that. What I need to do is change this calculation. But in doing so, I don't want to mess up all the previous people who have been using my function successfully without problems. So I want to add an argument which is sometimes specified and sometimes isn't, and which will default to a given value. And that's very easy to do. You just go into the list of arguments and add one at the end of your list, or more than that if you want. I'm going to call mine if metric, and you specify a type for it, which in my case is going to be a Boolean, and you set it equal to true. So what will happen now is, by default, this argument will be set to true, but I've got the opportunity to set it to false on my other calls. So both of those two lines will work, but obviously what I now need to do is I need to go back to my function and add additional syntax in here to cope with the eventuality I'm using imperial units. So to do that, I'm going to add an additional bit of calculation saying if I'm using imperial units, change my calculations. So to do this, I can say if not if metric. So if I'm not using the metric units, which I will be by default, then what I'll do is I'll take my height, set it equal to what it used to be, times 2.54, because there's 2.54 centimeters in an inch, and divide that by 100 to get my meters. Set my weight equal to what it used to be, times, divided by 2.2, because there's 2.2 pounds in a kilo. Otherwise, I'll leave everything as it was. So now if I run this program again, you can see a better oh dear, I was hoping it would go the other way. A better estimate of my BMI is 25.59, because I've given a more accurate estimate of my height and weight. So that's how you can add optional arguments. The most common reason I use them, to be absolutely honest, is when I've forgotten an argument, I've written a function, I've included it all over my code, and then I want to add the extra argument I forgot, and I want to make sure adding it doesn't mess up my existing calls to the function. And so I make it optional to make sure that I can specify my call to my argument with or without this extra call to the function with or without this extra argument. We've seen that you can pass an optional argument to a function, but you can actually specify that an argument should have optional size, so whether it's just a single item in it or lots of items. What this section of the tutorial will do is try to explain an example of when you might want to choose this. I must be honest, I don't use it myself that often, and this is slightly for the sake of completeness. So let's say we have a few files listing out films, similar to the ones we used in the previous tutorial. Taking the animation one at random, I can open that in Notepad and see that it gives me a list of all the animation films. And what I'm going to do is import all the lines but the first one for the animation file. What I'll then do is extend it so I can import lines for lots of files at the same time. So to get this to work, what I'm going to do is firstly create two variables. The first one I will call file path. And I've got this in my clipboard, so I'll set it equal to, let's paste that in. That's where my files are stored. And then I'm going to create another variable to create an empty list. And this will be populated with all the lines that I want to use. To do that, I can just put two square brackets, one after the other. Now what I'm going to do is define my function, which will read in the lines of a file. So I'll call it read file. I'll pass in a single variable, which is the name of the genre. Because this function is adding lines to my list, it doesn't actually need to return anything. So to stress that, I'll say that it doesn't return anything. It's called void in C# for anyone who knows that. Now I can read in my file, so I can say with open. I can put my file path in, and then concatenate onto that the genre I passed in. But then I also need to add on to the end of that the .csv to get the full file name. And I'll call that genre file. With that file open, what I'm now going to do is to read in the lines, and I'm going to store them in a variable, which I'll call genre lines. To do that, I can take my genre file, read in all the lines from it, split the lines so that I've got one item for each line, and then pick out everything from the first line onwards, from the second line onwards. So basically I miss out the first titles line from the CSV file. And then finally in my function, I can add these lines to my array, to my list. Say lines.extend. You can see it's extend because that takes as an argument an iterable set of things which I can add onto my existing list. So I'll add in the genre lines I've just read in. That's my function. Let's now see if this works. So I'm going to read in lines from one file. So to do this, I'll call my read file function and I'll pass in the word animation. It's not case sensitive, by the way. What I can then do is print out the lines. To do that, I can say for line in lines. Bear in mind, lines is a list which I've accumulated by running my function. So for each line, I'm just going to print it out. I don't think we've used a function like this before. Rather than storing the value returned from the function in a variable, we're just calling the function without attempting to output anything from it or to capture any information returned from it. So if I now run my program, you can see it lists out the lines in the animation file. And finally, I can get to the point. What I'd like to be able to do is to pass in other bits of information. So what did we have? We had animation, we had comedy. Let's have musicals in as well. So I've missed out the first one. And I'd like that to print me a list of all the lines in all the files. But it won't, because I said it took one argument and I provided three. What I can do is magically put a star in front of the name of my argument. And what that will mean is it has basically infinite possible length. There might be a single item in it, there might be lots. To make it clear what's going on, I'm going to put an S at the end of my argument. So I'm going to go genres. If something can be plural, I like to have an S on the end of it. And then what I'll need to do is amend my code here. So I'm looping over all the genres. There might not be any, but there might. So I can say for genre in genres. just need to indent that code and the rest of it will work okay. So what will happen now when I run this is it will pass in 3 string items. So the length of this extensible argument will be 3 items. It'll have 3 items in it. It'll loop over each item in that collection, if you like, and open up the file and add the lines to my list. And then finally, it will print them all out. Let's see if it actually works. So if I run that, you can see I've got my animation, I've got my comedy, and I've got my musical lines, which is all well and good. But the thing which always strikes me about this is why didn't I just create this as a list and pass a list into my function instead? So I did say I was adding this for the sake of completeness, but I feel duty done now, and I can move on to the next part of this tutorial. So as well as passing in a single optional value as an argument, you can actually pass in a dictionary of arguments. And what I'll try to do in this example is explain how you do this and when you might use it. Although, again, I'm not absolutely convinced this is an essential part of your Python armory. Let's suppose you had a list of films, as we've had so many times, and you want to possibly print out the name of the film when it was released. To do this, you might contain a set of arguments. The first one would be the column number, which gives you the column number to pick out. In this case, it's the 3rd column in our list of films. And the linked text would be the words it was released in. Now you could do the same thing to produce different output. So if you might want to show how many minutes each film lasted, and in that case you could use the same set of arguments, but this time you could pass in the column numbers 4 and the linked text as lasted for this many minutes. And you'll get a different output because you've got different inputs going in. To get this to work, you could create a dictionary of arguments, and the dictionary would have 2 elements. The first one would have a key of column number, which would be set to 4 for the second example, and the second key would be linked text, which would be set to lasted for this many minutes. Bear with me with this. So let's now have a look at this in practice. I'm going to use the example of musical.csv, a file we've seen before. And if we open that up in Notepad, you can see that it contains a title line, which we'll miss out. And then it contains, for each line, 5 bits of information. The idea of the film, the name of it, or the title, when it was released, how long it lasted, how long it lasted, and the genre. So what we'll do is read that information in, and then according to the value of the arguments we pass in, we'll print out one of those columns with some linked text before it. So to do this, I've created a file called argumentdictionaries.py, and I'm going to open up my musicals CSV file. And I can do that in the usual way by saying with open. I happen to have the path and the file name in my clipboard, and I'm going to say as, and then I'll call it CSV file. For each of those, each file, I'm going to print out or loop over all the lines in it. So I can say for line in, and I can take CSV file dot, I'm going to read in the entire contents, split the lines, and then take everything from the second line onwards. So what that will do is loop over all but the first line of the CSV file. And then what I want to do is I want to print out the information according to my function, which I haven't yet written. So I'm going to take a bit of a digression now and write my function. Now, I could write the function down here, but the problem with that is I would be trying to call it before I'd even written it. So I need to make sure that my function is at the top of my module. So to do this, I can define a function. I'm going to call it print info, and I can pass in 2 things. The first one is the line of text I'm going to print out, which will be a string of text. And the second thing is the extra arguments I'm going to pass in, which will be a dictionary of extra things. And the way you specify a dictionary of extra arguments is by putting a double star in front of it. And I promise that's the last extra bit of punctuation I'm going to show you in a function definition line. The thing isn't going to spit anything back out, it's just going to run and stop, so I'll just put that it spits out none. What I can then do is print out the line. To do that, I'm going to create a variable, I'll call it bits, which will take the line I passed in and split it by the commas. It will give me a list with 5 items in it. What I can then do is work out which bits I want to pick out. and display them. So the link text that I want to display is going to be, and this is where you're going to have to take a holistic view. It won't make sense till I've done everything. In my dictionary called extras, there's going to be an argument passed in called link text. I might as well give it the same name. That will be the text I want to display between the title of the film and the bit of information I want to display. And then I'll also have another variable which I'll call column number, and I'll set that to be the value of a dictionary key called column number. So what I can then do is print out the information. So I'm going to print out the name of the film, which is the first item in the list. Then I'm going to put a plus in. Then I can put my link text in. Then I can put the value of my column number, or the list element with that column number. Okay, so now I need to go back to my previous code, and I can use my function to print this out. I can call my printinfo function, and I guess I'm coming to the whole point of this now. I can pass in the line I want to print out, and then I can specify one or more, as many different arguments as I like. So I'm going to pass in two arguments, which I'll need in my function. The first one will be the column number, and because everything's numbered from from 0, to get the release date, I need to put 2 there. And then my link text B was released on. You're still following this. So now, if I try running my program, you can see it says when each film was released. And I've actually made a slight mistake. I should have been picking up on the film title, so I'll just run that one more time. And you can see it when it was released. But then if I go back to my function call and say instead I want the next column along, they lasted for this many minutes. I run that. You can see it gives me different information. So that's how you can pass a dictionary of arguments to a function. You precede the argument with a double star. But yet again, I would ask, why would you want to do it? I've had to go to quite some lengths to think of an example for this, and I just can't see why you wouldn't pass these as separate arguments. So unless I'm missing the point, I think this is another bit of this tutorial which you can probably consign to the back burner. So as a final part of this tutorial, we're going to look at Lambda functions. I think I promised this before earlier in a previous tutorial in this series. I've created a file called lambdafunctions.py, and I've added some comments which I'd just like to go through. So Lambda functions are also known as anonymous functions, and they're a big deal in many other programming languages like C#. C# programmers can get very excited about them. But in Python, all they do is provide an alternative way to write a function. And what this means is they're eminently dispensable. You don't need them. They're just an extra tool in your armory. The main two reasons to learn Lambda functions are so that you can understand examples quoted on sites like Stack Overflow, and so that you can impress your friends, but that's just my personal opinion. You can only rewrite a function as a Lambda function if it only contains a single return statement, so it can't do anything more complicated than just returning something. So we're going to look at three things. We're going to look at basic Lambda functions, naming them, and using multiple arguments. Before we do any of those, let's create a function. I'm going to call it cube because it's going to cube a number. I'll pass in the number to be cubed. I'll say it's a float, and I'll spit out from this float. So what I can do within my function is I can return the number raised to the power of 3. Now if I try testing that out, I can print out the cube of a number, not like that though, and I'll print out the cube of 4. And when I run that, you can see it gives me 64, which is pretty much what you would expect. This is an ideal candidate for a Lambda function because it doesn't do anything, it just returns a single expression. So what I'm going to do is I'm going to comment that out, and just for the moment I'll comment this out as well. And I'm going to rewrite my function as a Lambda function. So to do this, I can type in the word Lambda, And then I now need some way of referring to the input going into this function. It's traditional to call it x, but in truth you can call it anything you like. I then put a colon in, and the bit to the right of the colon is the expression which comes back from the lambda function. So in this case, you take the input and you raise it to the power of 3. And that is a lambda function. Now to use this, and here's some weird syntax coming up, you can do this. You can say, that's my function, and here's the argument it will take. So let's do exactly the same thing. Let's cube 4. And just to prove this is going to work, I'm going to store the value of that in a variable. Let's call it test cube. And then I'll print this out. Run that, it will give me 64 again. So all this is doing is rewriting my cube function in a different way. Now that's not a particularly user-friendly way to write a lambda function. The syntax is really difficult, and it means I can't reuse this again later. So what instead most people do is they use a named lambda function. So what I'm going to do is just edit this because that wasn't really very useful. I'm going to call my function cube, equal to that, and then just get rid of the bit at the end. And then get rid of that, and then comment this back in. What I've done here is I've created a function which is every bit as valid as the previous one was. It takes in any number x and spits out x cubed. You'll notice there's no attempt to try to say hint at which data type I'm passing in and getting out, and there's no other statements possible. So if I run that now, you should see I get 64 back out again. And that is what a lambda function is. You'll probably already know whether they're for you or not. So let's just do one more example with multiple arguments. So what I'm going to do now is create a function which will, given somebody's first name and their last name, will join them together and give you their full name. A fairly modest requirement, but again it satisfies the needs of a lambda function that it should only do a single thing. So to do this, I'll create my lambda function to create or return, I suppose would be a better word, someone's full name. So I will call it full name with the word lambda in. And this time I'm going to call my two arguments more descriptive things because I can. So I'll call my first one first name, and I'll call my second one last name, and then put a colon in. And now I can put any expression which refers to either of those two arguments. So I don't need to put the word return in. In fact, I can't. That's automatic. That's what lambda functions do. So I can just refer to the first variable or first argument, put a plus in, add in a space, and then put in the last name. That's it. So I've created a lambda function. I can now call it. So I can print out full name, and let's pass in, I'm sorry, I'm running out of imagination towards the end of this tutorial. I'll use my own name. And if I run that, you'll see it gives me Andy Brown. And that's what a lambda function is. It's just an alternative to a normal function. And they're only possible to use them when you have a function which only has a single return statement in.